All right, without a doubt, the most popular thing that I do in my class over the entire year is something called a house party. I use this idea of a house party in the front of the classroom to point out equilibrium and how you do the calculations for it. I have dance music going on, and we simulate a bunch of college students coming together in the evening for a party. And we watch a variety of different stresses occur over the course of the evening, and we keep calculating Q and watching it become K. Now, if you see the video of this, you understand it completely. But I'm going to look at it mathematically here with some boxes and some little B's and G's to show you the same sort of thing so that you can get an appreciation for it. This is a nice game we're going to play. Here's the game in action. The game says, I have a party. And the party is a party in a 2-bedroom house. Out in the front room is where the people hang out, getting to know each other. And in the back room is where the couples go to sit on a bed and kiss. All right? Now, there is a chemical reaction describing this process. In this chemical reaction, one boy and one girl make a boy-girl. Now, what they're doing, I don't know, holding hands, kissing, talking, who knows, making plans for the future. But this is the reaction we're talking about. Notice that it's an equilibrium process in which the boys and the girls can go to the right, and then when they've done whatever they've done, the boys and girls can go back to the left. So down here, in my little room that I've got going on, I've got boys and girls out here, couples back here. At equilibrium, the boys and girls go into the back room at exactly the same rate as the boy-girl couples in the back room finish whatever they're doing and go back out to the other room. So you have this constant back and forth, back and forth. I need a rule to describe this, and the rule to describe this comes from looking at the reaction quotient of the boy-girl couples in the back room to the boys and the girls as singles in the front room, and I'm going to create the rules for the party. Here they go. K at this party is equal to 0.5. That's the rule. The equilibrium constant for this house party is that the ratio of boy-girl couples to the ratios of boys and girls must always equal 0.5. You can stress the system all you want, but at some point it's going to come to equilibrium with K equal to 1/2. All right, party time. Point number 1. Young night. 4 boys show up at the party, 4 girls show up at the party. The party is young, it's alive, lots of possibilities. What is Q at this point? Well, here are all these kids in the outer room getting together, mingling, getting to know each other. I need to ratio the number of boys and girls in the back room to the number of boys and the number of girls in the front room as singles. The answer is 0 over 4 times 4. 0 over 16 is equal to 0. Q is not equal to K. But you see, that's unacceptable. When Q isn't equal to K, it's stressed. The system is stressed. When you're sitting out here and you've got 4 boys and 4 girls and you've got an empty room back here, something tells me something's going to be driving them in that direction. Well, right about this point is when I start playing some Marvin Gaye music. Let's get it on. And the next thing you know, people start to move. And what ends up happening? Well, we know what ends up happening. Got no choice. K is equal to 1/2. So I asked the couples to arrange themselves such that when it's all said and done, the 4 boys and the 4 girls do whatever they're going to do, get to the point where K is equal to 1/2. K equal to 1/2 means that the boy-girl in the back room as a numerical value over the boys times the girl in the front room has to equal 1/2. So the people start moving around, Marvin Gaye's playing, and then when you're done, this is the result you get. Notice there are 2 boy-girl couples in the back room, and there's a boy and a boy and a girl in the front room, and the answer is 1/2. 2 over 2 times 2. What's interesting, though, is that this is the macroscopic view of this, that K is equal to 1/2. The truth is that as long as no stress happens to the system, Every time that boy-girl couple finishes kissing and holding hands and walks back out this way, another boy-girl couple meets up and goes in the back room. And then that couple there finishes holding hands or whatever. They move out to the front room right about the same time as a boy-girl couple moves to the back. So you have this constant back and forth, back and forth. As long as k stays equal to a half, everybody's happy.